Hello, everybody. Welcome to episode 1 of Aspect Insights. I'm your host, Alex Eagle. I'm the co-founder of Aspect. We're a company that makes a Bazel-based monorepo developer platform, and we'll talk about more of that later. For today, in our first episode, we want to talk about protocol buffers, and in particular, the rules proto and the Protoc C executable that we're all used to compiling, and some work that we've done recently to fix this up. With me on our first episode is my coworker, Shaheen. He is an amazing software engineer. We met him working together on some GitHub repos. Lucky that he joined the company. He's the author of Rules OCI, which many of you know as the logical successor to Rules Docker. And he also knows a lot about protocol buffers. He wrote one of the TypeScript protocol buffer generation plugins. And so I'm very excited to welcome to the stage Shaheen. How's it going?
Good. Hello, Alex. Nice to be here. As Alex mentioned, I'm Shaheen, working at Aspect, the Rules OCI champion, and I know a lot about Proto ecosystem as a whole. So today I'm here to yap about, the problems in the ecosystem and how we fix some of them, but there's still, work to do.
There sure is. Yeah. Well, let's talk about the history a little bit. It's always good to start with storytelling. Protocol buffers is very popular technology that came out of Google, and Bazel is, of course, as well. So we would all expect that these two things should work pretty well together. And I think there's been like the rules proto repo is a start, and it's always given us a place to load a little bit of the functionality, but then a lot of the functionality was missing. And so has stackb/rules proto on GitHub, which adds a bunch of stuff on top of rules proto. There's also rules proto-grpc from Adam Liddell. And in my experience, a lot of users are using one of those two things because the stuff that came out of Google, like the repos in the Bazel build org, didn't really solve all the problems, right?
Mm-hmm. Yeah.
So I'll share my screen a little bit and give a little bit more history here. We have this Rules Author Sig, or Special Interest Group. This started a couple years ago, was announced at BazelCon. The goal of this Rules Author Sig is to bring together people working on all the different Bazel rules and give them the sort of shared support that they need to make a consistent experience that works well for Bazel end users. And so one of the projects that we did was looking at this fragmentation. I mentioned Paul Johnson's repo and Adam Liddell's repo. And so we brought them into this into the SIG, and we said, hey, we can fund a little bit of work. Thank you very much to all the sponsors of the SIG. We can fund some work to try to explain what's going on here. And so that's this page I'm showing here. This documentation is trying to show, like, what's the problem being solved. So you have these rules in Bazel called proto library. We'll look at these in a minute. So these are just declaring what proto files you've written. And when you build a proto library rule, you just get a descriptor file. That's not really interesting or useful. So you need more rules on top of that to generate code for individual languages and to be able to load that into the runtime so that you can actually marshal protocol buffer messages and use grpc to make remote procedure requests. So there's a spreadsheet in here, which is the beginning of the end, right? You don't ever want to read documentation and find a spreadsheet embedded in it. And the spreadsheet is trying to show you, okay, across all the languages, across all the rule sets, what are the currently viable options? And when I say currently, don't believe me, this is definitely was current as of a certain time, right? But it's impossible to keep this thing up to date. And there's this whole section about which rule set should you pick, and this fragmentation is kind of scary. To be clear, we're not solving all of these problems today. That's not the announcement, but this is just giving some of the history about why this is a hard problem space. I also wanted Shaheen to give a little plug here to your repo, protoc-gen-ts. Give us a little bit more of your experience there. So let's talk for a minute about the more specific problem that we are here to solve today, which is at the very base of all of this, I said the proto library rule needs something to run to create a descriptor set. That thing is Protoc C. Protoc C is the protocol buffer compiler from Google. Pretty much everybody who uses protocol buffers, somewhere underneath their build system, Protoc C is a tool that's being invoked to create the descriptor, but also it has some built-in plugins. So if you say -- Python out, then it will generate Python stubs, for example, that you can then load into your Python application to marshal and unmarshal protocol buffer messages. And Protoc C is published on the releases for the protocol buffers repo. So it seems like it should be a pretty easy problem to solve. That's not the way it works. So Shaheen, do you want to explain the way it actually works today, at least before the changes we've made?
Yeah, I could give a little history there. So the whole Bazel protobuf ecosystem, I'm not sure, but my guess is that it started at Google. As you know, Google builds everything from source, and they have everything vendored in their monorepo. So those rules started from there. Most specifically came from Bazel itself as a native rule, and then later ported to Starlark, but that's not important to the story. So the proto rules, the problem with the proto rules was that it was really specifically designed for the Google's needs. And therefore, when you try to use it with any project outside of Google, it was pain to work with. It had a couple issues. One of them was it always tried to compile the Protoc C from source, even though there was, as Alex mentioned, there was pre-built binaries available. And later they fixed it by doing some trickery in Bazel, which tries to download the pre-built binaries, and then if it's not available, then fallbacks to sources and then builds from there. And that was an annoying experience because Proto library wanted to get Protoc C in something called tool configuration, and that meant, I don't know if everybody here is a Bazel expert, but if you have a transition, which let's say you're on a Mac and you're trying to build some project that has Proto stuff in it from Mac to Linux, then that meant that you had to recompile Protoc C again and again. And in a big monorepo, that was a problem.
Yeah, thanks. So that's probably a good segue to watching Protoc C compile. So I've got a little VS Code window here that we can use to play around with. So let's see, what command do we want to run? Maybe I'll just start with examples ... So there's some examples in this repo, and we're watching Bazel build, and here we are compiling Protoc C from source. Mm-hmm. And it finished already, so that's pretty good. Let's do a clean just to simulate what happens if there's a some sort of cache bust that happens in the build. Not that users would necessarily clean, but if they were to have a cache miss on Protoc C, here we are compiling it again. And probably many of you have seen this. So it just spit out a bunch of warning spam. Am I supposed to fix this sharp define thing inside of Xcode? I have no idea. Something is obsolete, so I will regret it. I'm compiling for C#, even though I don't use C#. I'm compiling, you'll see PHP going by because we have to compile the PHP support inside of Protoc C. Some more warnings just got spit out, and it's linking, and now we're ready to finally run it. And so we just spent 33 seconds on a build that kind of sucked. And all the warning spam kind of sucked. Even worse, this build could have failed if my local C++ toolchain wasn't set up properly. And of course, Bazel doesn't come with a hermetic toolchain out of the box. And so even if it's working on your machine, your coworker might clone the repo, do the build I just did, and get an error from Clang or LLVM or whatever C++ toolchain you have wired up. So it's not even guaranteed that this will build for you. And if it does, it's slow and makes a lot of errors, a lot of warnings. So kind of stinks. Let's take a look at the code here for a second. And I'm just going to dive into exactly what thing is we just built. So here is a proto library target. And the protocol buffer itself is the shortest possible thing. Essentially, it's got a string, and it does use one of the well-known types from Proto. So this will keep us honest because we do need to load this from somewhere. And so let's do the clean again. And this time, instead of building everything, let's build just this one proto library target. Example is foo_proto. So all I need to do here is generate that descriptor. I'm not generating any language output yet. We're not running Protoc C to produce any stubs. And it's going to be that same 30-second build, obviously, because the one step that's required here is to build Protoc C from source. This package does also have a PyProto library and a Java proto library. So as we talk through what we've done to fix this problem, we'll have to show that those are working as well. Okay, so it makes me very sad to watch Protoc C compile. I spend a lot of time watching Protoc C compile. I don't even get to code that much, and I feel like I spend a lot of time watching it compile. Shaheen, how much time have you spent watching Protoc C compile?
That's a lot. That would probably cost Aspect or our customers a lot of money. Maybe an hour every day.
Right, and there's also this aspect of it that, so for example, Stardock depends on protobuf. And so Fabian Murmertime, who's helping out with this effort, works at BuildBuddy, and he pointed out just a couple days ago that because of that, even just generating documentation in a GitHub Actions that could be fast is also going to take this extra time on every build, since there's some binary from the proto repo that's in the path. Okay, cool. So now let's pivot a little bit and talk about what happened. What's the next step in the story? So this problem is sort of known to exist. Derek Perez was on the protobuf team at Google. Now he's working at Buff. He came and reached out and sort of made a relationship where we had an opportunity to talk to the protocol buffer team and get involved with what their goals were. At the same time, one of the engineers from the Bazel team, Ivo List, was planning on taking the Basil toolchain feature and applying it to how the protocol buffer compiler is resolved. So Shaheen, I'll probably give you a chance to describe this one as well. Like what are Basil toolchains and why is it useful in this context?
Yeah. So the Basil tool. So let me back up a little bit. So every artifact that you have is produced by a tool, right? Whether it's LLVM, whether it's GCC. In this case, it's Protoc C. And as I mentioned before, Protoc C at best fetch pre-built if you have a recent version of Rules Proto. If not, it's going to be compiled from source. So Basil Toolchains is a feature that Bazel implemented a couple of years back, which kind of separates the concern of where the tool comes from to I just want this tool. What I mean by that is that let's say you have a recipe which requires a Protoc C, and instead of saying, okay, go to shop A and get me Protoc C from there, you just say, I want Protoc C because it's in my recipe. I need that to make something, build an artifact. But with Basil Toolchains, what you say is, I want a Protoc C. I don't care what it comes from. Even though so this is the whole story about toolchainization of proto rules in Bazel, which allowed things like you could bring in your own Protoc C binary. You could fetch it from the pre-built releases. or you could compile it from source if you want to. So that's the Bazel Toolchains feature, basically. I wanted to say something else.
Yeah, well, maybe the next thing to point out is that Ivo had a proposal for how to do this. This is the issue that was filed on Rules Proto. And so the first thing that had to happen was changes in Bazel itself, because the references to the location, the hard-coded location of Protoc C, were baked into the Bazel binary, like in the Java code. And so for Bazel 7, this had to be fixed.
Right. That's actually the story that I missed. Thank you. Yeah. So a lot of the assumptions around the Bazel protobuf rules is that Protoc C comes from a specific label, from a specific repository, which is com Google protobuf in this case, which meant that rule sets like rules proto had to implement workarounds such as faking out a repository rule that is named com Google protobuf, which kind of looks like the original repository. But with toolchains and everything, that's completely gone. No longer we need that a workaround, basically.
Yeah, cool. So the magic happened in the Bazel 7 release. So there's a new flag. It has kind of a long name: incompatible enable Protoc C toolchain. No, incompatible enable proto toolchain resolution. And of course, Bazel had 700 flags, so now it has 701 flags. We're sorry, but that's sort of a necessary ingredient of rolling this out because it is a breaking change. So let's look at this code again, and we'll see how to make use of it. So the magic is in the Bazel-rc file. So I'm in this example repo. Here's the flag I just mentioned, which is currently commented out. So let's say I turn on incompatible enable proto toolchain resolution. Let's do a clean again, just to make sure that I'm being honest. And now I'm going to build foo proto. And it's done in 2 seconds because instead of building Protoc C from source, it went and got it from somewhere. And like Shaheen mentioned, it doesn't say here where to get it from. That's the job of whoever registers toolchains. And so I'll show where we registered the toolchain for this in a moment. This flag, importantly, it's not only Protoc C that gets turned on here, but each of the language-specific rules may also need to go and locate something like, for Java, it needs to find the protocol buffer runtime, which is an extra jar file that needs to be on the class path at runtime for the protocol buffers marshalling and unmarshalling to work, right? It's not all generated stub code. The generated stub code needs to import from some runtime library. And so this flag is turning it on both for the proto library rule, but also in our example, that flag turned it on for PyProto library and Java proto library as well. So there's kind of like an ecosystem-wide rollout that has to happen. So Shaheen, I know you made you may have had to make a pull request to rules Python for this, for example. Do you want to talk about that a little bit?
Yes. So implementing this toolchains feature for proto library was a task on its own, but we also had to fix shout out to Ivo for actually doing the most of the heavy lifting, fixing the proto library in Bazel, because I did not really fix that part. It was all him. But we also had to fix the whole rule set ecosystem around proto and Bazel, and Python, Java, C++. They were all one of those. And the latest one that I sent to rules Python is basically, so the rules Python had a proto library rule which only wanted to get Protoc C because Python is a language that is built into Protoc C, so you can generate your code just using Protoc C. You don't need to fetch any external plugin. So what we did there was to introduce a new toolchain type for PyProto specifically, and get rid of all hard-coded labels in the rule so that instead of, again, saying, I want Protoc C, it said, give me a Protoc C. I don't care where it comes from.
Yeah, cool. All right, so let's take another look at this, at the code here. So that means that we're going to have to supply not only a toolchain for proto library, but also something for Python. So let's disclose what this actually looks like. Let's say you as a user want this to happen. So I mentioned you turn this flag on. This turning on this flag is not the only step you need to take. You also now need to register some toolchains. And so we've got this package in here called lang_toolchains. And so there's two things in here. So one of them is a proto-lang toolchain rule. In this case, this is the one for Python. It says, hey, you're going to call Protoc C with this command line. You're going to say -- python out equals, and then the %s here is going to get replaced with the path that it wants to generate the Python stub. Progress message is just the thing you're used to seeing from Bazel. If this takes a while, it will get printed. And then it also wants to point to the runtime. So this is the library that's going to have to be linked into the application in order for the proto marshalling and unmarshalling to work. In this case, we're getting it straight from PyPy. So we're not getting this from the Google protobuf repo either. This is the way you would get it if you were in some other build system. And that's an important part of our philosophy with this approach. Bazel doesn't have to be weird. It doesn't have to be sort of Google 3-like. Instead, it can be like Maven or PyPy, like the way that you would normally use protocol buffers with some other build system is you would get the runtime from here, right? Same thing for Java. So, -- Java out is the flag, and then the runtime is some jar file. You could get this from Maven. In this case, to make the example even simpler, I'm just using HTTP jar. That's literally it, right? I'm just getting it straight from repo1.maven.org so that we have the runtime available. And for Python, here was the requirements file that generated the PyPy index. So this uses the standard rules Python stuff. Okay, so then the last part is Bazel toolchains are a little bit complicated. There's this extra step of indirection, and it's extra confusing that there's a rule called toolchain that has an attribute called toolchain, and then another attribute called toolchain type. Like, don't worry, like these are short. It's basically just hooking this thing up as a registration. So we take our Python toolchain that we just declared above. So that's this line, and then we have to tell Bazel, okay, use that. If somebody asks you for the Python proto toolchain type, then register mine. Similarly, if somebody asks you for a rules Java proto toolchain type, then use the one I just declared, right? And then there's a final step at the very end, which is we need to point Bazel at those toolchains with this call here. We need to say register toolchains, all of the ones in that package I just showed you. So that's how you wire up all of this as an end user. Yeah, I mean, I like it. I think it does require a little bit of code in your repo, but on the other hand, it means that you have full control over, for example, what version of the Java proto runtime you're using. And that's important because you're probably, for a lot of folks, you're doing a migration from something else. You want to keep the versions the same while you're doing a migration. You don't want to accidentally change versions. And this means you can upgrade the version of Protoc C independently from the version of the runtime if you need to, right?
Yeah. Alex, am I allowed to do a live code review?
Yes, please, of course.
Yeah, so you have the tool chains in the bottom. So if you, I'm 99% sure, 1% wrong. If you put the toolchain type attribute directly on the proto-lang toolchain, it will also create a toolchain target for you as well. So you don't actually need those.
That sounds magical. I'm going to try that after the broadcast, just to make sure we don't show people broken things. Unless you want to try it live, we can do that at the end.
No.
Okay.
We can just move on.
Yeah. So let's take about 5 more minutes. I think the last thing we should show is, well, I guess we should show 2 more things, right? One is, what does it look like inside of this repo? Like, how did we manage to fetch Protoc C? And the second thing is, what does it look like if you're a rule set author? Then there's some work for you to do to wire this stuff up. Like we showed Python and Java here, but Shaheen's not going to go to every rule set in the world. So we're waiting on other folks to make some fixes to remove the hard-coded references to the Google protobuf repo. So this examples folder that I've been showing so far is inside of a repo called toolchains_protoc. This is on the Bazel central registry, and you can grab it, and you simply need to make a Bazel dep on it. And in this case, I'm actually choosing the version of Protoc C that I want. And this repo automatically has all of the versions included. We have some nice GitHub Actions automation for it. So you'll see like the current release candidates of version 27 are already in here. Like the minute they come out, they get mirrored into this repo. And this is not even the head of the upstream right now. There's also a tricky bit in here to this line. So when we took away com-google protobuf that was providing Protoc C, we also lost the well-known types, right? And we are using those in our example. So if we look in the right here, how did this line work? How did we reference any proto if it comes from com-google protobuf? And the answer is that this toolchain's Protoc C registers both the Protoc C toolchain type, but it also can create this com-google protobuf repo that contains just the well-known type declarations. It still gets them from the same release that's published by the proto team. So this is not fetching the protobuf repo. It's just using what they published in their releases, because they always include the definitions of these well-known types like any and timestamp and so on in every release archive alongside Protoc C. So yeah, behind the scenes, essentially there is some long stuff here, but this is where we hook up that repo I just mentioned for each of the well-known types. We have to extract them out of the thing we downloaded. Here's where we declare those, and here's where we declare the pre-built toolchain. And then in this other file, oh, sorry, I was hoping to show the actual fetch. Right here. This is it, download and extract. So the URL here is protocol buffer / protobuf / releases / download / something. So we're literally just taking their release and exposing it into Bazel as a toolchain. Yeah, cool. So that's what it looks like for a user. I guess the last thing we should show is maybe a little bit of how somebody would update their rule set. And so for that, the first thing I'd like to do is go back to the Chrome window here. And so here's the 6.0 release of Rules Proto. So it mentions this toolchain's Protoc C, which of course is not the only way to use this. This is just a rule set that we put together. Originally, my hope was that this was going to land in Rules Proto itself, but so far that's been rejected by the maintainers. And the other important bit is, I've lost my, let's see. Here, so on Rules Proto, we have a new discussion. This is number 213. Obviously, we'll paste this in the show notes. And this is a list of all of the repos that need updating. And so Stardock, there's a PR up to fix this. Rules Swift, there's an issue. For Rules Go, it's already fixed. We're just waiting on a release. Thank you, Fabian, for fixing that. For Rules Rust, there's an issue. Rules Python, like we said, is already fixed. Rules TypeScript, I think I fixed yesterday, preparing for this. And so if you see, if you tried this out and it doesn't work, then it's probably that there's still a lot more hard-coded references to com-google protobuf that are still out there in the ecosystem. And we need your help. So please come to this issue 213 and let us know what else is missing. And volunteers from across the Bazel ecosystem are standing by to make all these fixes so that we never have to compile Protoc C again. So yeah, I don't know, any other closing thoughts here, Shaheen? How much fun was it to get to work directly with the Protocol authors team at Google?
Honestly, it felt good because we at least fixed some of the problems in the Bazel Proto ecosystem. It was also a little painful because we had to, decide, do it the Google way or do it the open source way, which created some conflicts. But yeah, overall, I'm feeling good.
Yeah, I think it's also a good demonstration of how clever the toolchain feature is in Bazel, because this layer of indirection means that now anybody is free to supply the Protoc C toolchain. And we didn't mention it earlier in this demo, but you're free to continue using the one that's built from source. You just need to register that toolchain first, and then Bazel will resolve to that one.
Yeah.
And so it's nice because it means that like this toolchains Protoc C repo is, we can iterate on it as quickly as we'd like. Somebody can fork it and work on it in their own repo. It's no longer buried inside of Bazel's Java code.
Yeah. And I also like to say all this talking, we are not trying to villainize compiling from source, because sometimes it's the right thing to do. But you still have two options. Now you're not forced to just compile it from source. Now you have the both options, and it's up to you to do what.
Yep. Awesome. All right. Well, thanks for being my guest today, Shaheen. And thanks to everybody for watching episode 1. We will be back next week and talk about the 2.0 release of rules.js. So hope to see everybody then. Thanks a lot.
Thank you.